morning, students. This is M. Prasantaraju, Department of Physics, ELURU College of Engineering and Technology. Today, the lesson that has given for this class is from Engineering Mechanics, Unit 3, called Centroid and Center of Gravity. First of all, we will discuss about the definitions of centroid. The point at which the moment of area is assumed to be concentrated is called centroid. Center of gravity. The point at which the moment of volume is assumed to be concentrated is called center of gravity. And next, we will see the differences between centroid and center of gravity, how they will differ. Differences between centroid and center of gravity. We will decide the differences between centroid and center of gravity. I will split the page into two columns. The first column is centroid. The second column is center of gravity. The first difference comes under centroid is the definition itself is one of the difference. Hence, the point at which the moment of area is assumed to be concentrated. The first difference in center of gravity is the point at which the moment of volume is assumed to be concentrated. The second difference in centroid is it is applicable for one-dimensional or two-dimensional. The second difference in center of gravity is it is applicable for three-dimensional. The third difference in centroid is the summation of moments of all areas with respect to centroidal axis C of x bar comma y bar. The third difference in center of gravity is the summation of moments of volumes of a given body with respect to center of gravity axis g of x bar comma y bar comma z bar. The fourth difference is it is denoted by C, and the fourth difference in center of gravity is it is denoted by G. The next subsequential topic after finishing this is determination of centroid by the following methods. Determination of centroids by the following methods. Number one, the first method is method of moments. The second method is method of integration. Let us discuss one by one. First one is method of moments. Consider the plane surface area with respect to centroidal axis C of x bar comma y bar. Now let us draw the diagram regarding this method of moments. This is OX axis, this is OY. Consider an irregular surface in XY plane. This is center of both the axes, x bar comma y bar. This is at a distance x bar. This is at a distance y bar. The first elemental surface whose centroid is represented by C1 of x1 comma y1 and its area is A1. The second elemental surface C2 of x2 comma y2 and its respective area is denoted by A2. The third elemental surface area is C3 of x3 comma y3 and its respective area is A3. Now let us discuss this diagram. Consider an irregular surface in the plane xy. Let this surface is divided into a number of elemental areas represented by A1, A2, A3 respectively. Let C1 is the centroid of the area A1 and let C2 is the centroid of the area A2, and let C3 is the centroid of the area A3, and so on. The total moment of area A with respect to y-axis is given by A into x bar, equation 1. The moment of area A1 with respect to y-axis can be written as A1 x1. The moment of area A2 with respect to y-axis is equal to A2x2. The moment of area A3 with respect to y-axis can be written as A3x3, and so on. Now the total moment of area, with respect to A1, A2, A3, and so on can be written as A1 x1 plus A2 x2 plus A3 x3 plus so on. I can call it as equation 2. Now equating 1 and 2, we get A into x bar is equal to A1 x1 plus A2 x2 plus A3 x3 plus so on, followed by our ultimate article is to get the expression for x bar. Hence it is x bar is equal to A1 x1 plus A2 x2 plus A3 x3 plus so on divided by A. That implies x bar is equal to A1 x1 plus A2 x2 plus A3 x3 divided by A1 plus A2 plus A3 plus so on. This is the ultimate expression for x bar. Next, we have to find centroidal y-axis. That we can write like this. To find y bar, consider the plane surface area capital A with respect to x-axis can be written as A into y bar, equation 3. The moment of area with respect to x-axis is equal to A1 Y1. The moment of area A2 with respect to x-axis is equal to A2 Y2. The moment of area A3 with respect to x-axis can be written as A3 Y3 and so on. Now the total moment of areas with respect to the three areas. Now the total moment of areas A1, A2 and A3 are given by A1 Y1 plus A2 Y2 plus A3 Y3 plus so on. I can call it as equation 4. Now equating 3 and 4, we get now equating equations 3 and 4, we get A into Y bar is equal to A1 Y1 plus A2 Y2 plus A3 Y3 plus so on. Hence, Y bar is equal to A1 Y1 plus A2 Y2 plus A3 Y3 plus so on divided by capital A. That implies Y bar is equal to A1 Y1 plus A2 Y2 plus A3 Y3 plus so on divided by A1 plus A2 plus A3 plus so on. Here Y represents the centroidal y-axis and A represents the total area. Since capital A is equal to A1 plus A2 plus A3 plus so on. Now, the centroidal axis with respect to x-axis and y-axis is given by C of x bar comma y bar is called the centroidal x and y axis. Next, we will go to method of integration with respect to x-axis and y-axis. Second method, the second method to find the x-axis and y-axis is method of integration. Method of integration. In this method of integration, we have specific formulas to find x bar and y bar. That is, x bar is equal to integral x dA by integral dA and y bar is equal to integral y dA by integral dA. Next, the continuation topic of this is determination of center of gravity. Determination of center of gravity in this again we have two methods. The first method is method of movements of volumes. Second method is method of integration. Let us discuss one by one. First one is method of movements. Method of movements of volumes. In this, we will draw the diagram like this. Consider origin O, this is y-axis, this is z-axis, and this is x-axis. Consider an irregular surface in yz plane. Let this surface is divided into a number of elemental volumes represented by like this. And at a particular point in yz plane, g bar of x bar comma y bar comma z bar called center of gravity. The first elemental surface is denoted by, there is a particular point denoted by g1 of x1, y1, z1, and its respective volume is v1. The second elemental area z2 of x2, y2, z2, its respective volume is v2. And the third elemental surface area, there is a certain point g3 of x3, y3, z3, and its respective volume is v3, and so on. Now I will discuss this diagram. Consider the three-dimensional axis in this yz plane, an irregular surface is taken, and this surface is divided into three elemental volumes which are represented by V1, V2 and V3 respectively. Now, the total volume V with respect to yz plane is given by V into x bar, equation 1. The volume of first elemental surface V1 with respect to yz plane is equal to V1 into x1. The volume of second elemental surface V2 with respect to yz plane can be written as V2 into x2. The volume of third elemental surface V2 with respect to yz plane can be written as V3 into x3, and so on. Now the total volume with respect to the three elemental surfaces Now the total volume with respect to the three surfaces is given by V1 x1 plus V2 x2 plus V3 x3 plus so on. I can call it as equation 2. Now, equating 1 and 2, we get V into x bar is equal to V1 x1 plus V2 x2 plus V3 x3 plus so on, followed by x bar is equal to V1 x1 plus V2 x2 plus V3 x3 plus so on, divided by capital V. Again, this can be expressed as x bar is equal to V1 x1 plus V2 x2 plus V3 x3 plus so on by V1 plus V2 plus V3 plus so on. This is the ultimate expression for x bar, which was going to be obtained in YZ plane. Similarly, we are going to get the expression for y bar and z bar in these respective planes like this. Similarly, the y bar is obtained in the xz plane is given by y bar is equal to V1 y1 plus V2 y2 plus V3 y3 plus so on, divided by V1 plus V2 plus V3 plus so on. This is the expression for y bar. Similarly, for xy plane, we will get the z bar. Similarly, the z bar is obtained in xy plane, which is given by z bar is equal to V1 z1 plus V2 z2 plus V3 z3 plus so on, divided by V1 plus V2 plus V3 plus so on. This is the ultimate expression for z bar. In this way, we are going to get the expressions for the three axes in three-dimensional to find center of gravity. Let three of them are represented by x bar, y bar and z bar is like this. Then next we will go for the second method, which is called method of integration to find the center of gravity axis. Second method. The second method is called method of integration. In this method of integration, we are going to find x bar is like this. X bar is equal to integral x dv by integral dv. There is a certain formulas to find x bar, y bar and z bar. They are like this. Y bar is equal to integral y dv by integral dv. And similarly, z bar is equal to integral z dv divided by integral dv. And one more formulation we have to express the center of gravity axis through this method of integration. They were like this. X bar is equal to sigma vi xi, where I is varying from 1 to n, whole divided by sigma vi, where I is varying from 1 to n. This is the exclusive expression for the center of gravity axis. Let it be denoted by x bar. Similarly, for y bar and z bar also represented by their respective formulas. Y bar is equal to sigma vi yi where I is varying from 1 to n, divided by sigma vi, where I is varying from 1 to n. Again, we have one more expression for z bar, that is z bar is equal to sigma vi zi divided by sigma vi, where I is varying from 1 to n, like this. This is the third expression called z bar. So these are the representations of x bar, y bar and z bar with respect to center of gravity axis, coming under method of integrations. Next, we will derive the expressions for centroid due to rectangle. Determination of centroid of a rectangle with base B and a height h. To perform this centroid of a rectangle with base B and a height h, we are going to split this into two cases. The first case is to find x bar, and we have a stipulated formula to find x bar, that is x bar is equal to integral x dA divided by integral dA. This is the standard formula to find x bar. And to find this x bar, we need to draw a diagram that this is origin, this is x-axis, this is y-axis. Consider a rectangle like this. There, one elemental area represented by dy, which is at a distance y from, which is at a distance dx is at a distance x from y-axis. From here to here is b, from here to here is h, we consider like this. Now the explanation of this diagram is as follows. Consider a rectangle of height h and a base b in xy plane. Let dx is the small elemental area is at a distance x from y axis. Let dA is the small area is with respect to dx. Hence, we need to write dA as dA is equal to h dx, equation 1. Now, to find x bar, integral x dA divided by integral dA in between the limits 0 to b. Now, first we will derive the denominator portion, that is a is equal to integral 0 to b dA. That implies integral 0 to b, we know that dA is equal to h dx. Therefore, in place of dA, I simply substitute h into dx. Now, I would like to differentiate this, integrate this h dx, that is as follows. That implies, as h is constant here, take out of the integral, h into integral 0 to b dx. We know that integral dx is nothing but x. Therefore, h into x in between the limits 0 to b, that implies h into b. This is the denominator portion of evaluating integral 0 to b dA. Now, bring this and substitute in equation 1, we get x bar is equal to integral 0 to b x dA by hb. That implies x bar is equal to 1 by hb into integral 0 to b x dA. From equation 1, we consider that dA is nothing but h dx. Therefore, bring it and substitute it there. We'll get x bar is equal to 1 by hb square bracket integral 0 to b x into h dx. That implies x bar is equal to 1 by hb into, as h is constant, take out of the integral, h into integral 0 to b x dx. As h cancel here, x bar is equal to 1 by b integral 0 to b x dx. We all know that integral x is nothing but x square by 2. That implies x bar is equal to 1 by b into x square by 2 and applying lower limit 0 to upper limit b. That implies x bar is equal to 1 by b into b square by 2. As b cancelled one time here, we get x bar is equal to b by 2. This is the coordinate of x bar in centroid of rectangle. Similarly, we have to find y bar. Let us see this. Determination of y bar. Determination of y bar, or to find y bar. To find y bar, we have a specific formula that y bar is equal to integral y dA divided by integral dA. And to perform this y bar, we need to draw a diagram. Let it be like this. Origin, x-axis, y-axis. Draw a rectangle like this. In that there will be one portion or small elemental area. Let it be denoted by dx, dy, and this distance from origin to this particular portion is called b, and the distance from origin to y axis is denoted by h. Draw this diagram. This dy is at a distance y from x-axis. To discuss this diagram, again, consider a rectangle of height h and a base b. Let dy is the small elemental area in rectangle which is at a distance y from x-axis. Let dA is the small surface area is with respect to dy. Hence, we can write this dA as dA is equal to B into dy. I can call it as equation 2. Now, to find dA, again to find x bar, y bar is equal to integral 0 to h y dA by integral 0 to h dA. First of all, we will solve the denominator portion, that is like this. Integral 0 to h dA is equal to integral 0 to h b dy, as we already considered that dA is equal to b dy. Now I am integrating this particular part by removing b as constant, b into integral 0 to h dy, that is equal. We all know that integral dy is nothing but y, therefore y in between the limits 0 to h, that is equal to b into h. Bring this particular formula into the main formula. Y bar is equal to integral y dA by integral dA in between the limits 0 to h. I can substitute the value of BH in the denominator portion. I will get y bar is equal to integral 0 to h y dA by BH. I can write this as y bar is equal to 1 by BH into square bracket into 0 to h y dA. We already considered the dA as b dy, therefore 1 by BH into integral 0 to h y into b dy. Again, b is constant in this particular formula. I will take out of the integral. Y bar is equal to 1 by BH into b into integral 0 to h y dy. As bb cancel here, we will get y bar is equal to 1 by h into integral 0 to h y dy. We all know that integral y is nothing but y square by 2. Hence, 1 by h into y square by 2, applying the lower limit and upper limit, that is 0 to h. Therefore, y bar is equal to 1 by h into, applying upper limit here, we get h square by 2. As h cancel one time here, we will get y bar is equal to h by 2. This is the expression for the y coordinate in centroid of a rectangle. Hence, the centroid of a given rectangle can be expressed finally as the centroid of a given rectangle with a height h and a base b is given by C of x bar comma y bar is equal to C of b by 2 comma h by 2. This is the methodology of finding a determination of centroid of a rectangle. In the next class, we will discuss about centroid due to simple figures, centroid due to composite figures, and centroid due to shaded region. Thanks for watching this class. Thank you very much.